I will be teaching the classification of analytical methods and gravimetric analysis. Analytical methods are scientific techniques used to identify, separate, and quantify the chemical components of a substance. It can be classified into two: classical methods and instrumental methods. Instrumental methods and classical methods can be again classified into quantitative and qualitative analysis. In classical methods, under qualitative methods, its examples are precipitation reaction, color test, and flame test. Whereas quantitative, volumetry like acid-base, redox, complexometry, gravimetry included. In case of instrumental methods, it's again classified into qualitative and quantitative. Qualitative include UV visible, IR, and mass spectrometry, whereas quantitative includes AAS, flame photometry, chromatography, potentiometry, conductometry. The classical methods are the methods which focus only on identifying the presence and nature of components. The simple examples include flame test and color test. Classical methods are also known as wet chemical method. Here, qualitative methods which focus on identifying the presence of natural components include flame test and color test. Whereas quantitative test is determine the exact amount of concentration of components, where gravimetry we are going to discuss. In instrumental methods, here the instrument is utilized to detect the presence and characteristics of substance. Examples: IR, mass spectrometry, UV visible spectrometry. In quantitative, here they measure the precise concentration based on instrumental signals. Example: atomic absorption, HPLC, potentiometry. In classical methods, there is no high instrument is used for the method and identification. Gravimetric analysis is a quantitative method based on measuring the mass of substance of unknown composition that is chemically related to the analyte, where analyte is a compound or species to be analyzed in a sample. The principle is very simple, that is, the mass of an analyte can be determined by converting it to a pure, stable compound of known composition and weighing it accurately. Here, the conversion into the pure stable compound is a must. Gravimetric analysis involves several precise steps to accurately determine the mass of an analyte. Here, majorly 7 steps are there, which include solution preparation, precipitation formation, digestion process, filtration, washing, drying or ignition, and weighing. In the first step, the sample is containing the analyte is dissolved in a suitable solvent at conditions like proper pH and optimum temperature, which are adjusted to optimize precipitation. In the second step, a precipitating agent is added to the solution, causing the analyte to form an insoluble solid that is separate from the solution, that is our precipitate. Here, when the solution, the ionic product exceeds the solubility product, the solution gets precipitated. Third step is digestion. Here, the precipitate is heated in the mother liquid, that is the initial solution, to encourage the formation of larger pure crystals that are easier to filter. For encouraging the formation of larger pure crystals, it is heated. Next step is filtration. The solid precipitate is separated from the liquid solution using a filter, ensuring minimal loss of the solid. Next, washing. Here the filtered precipitate is washed with an appropriate solvent to remove the impurities without dissolving the precipitate itself. So the choosing of the appropriate solvent is done carefully. Next, drying or ignition. Here the precipitate is dried in an oven or ignited at high temperature to remove all traces of solvent and form a stable weighable compound. Next, the dried or ignited precipitate is weighed accurately using an analytical balance to determine its mass, from which the analyte mass is calculated. Gravimetric factor. Gravimetric factor is the ratio used in gravimetric analysis to convert the mass of precipitate or residue into mass of analyte it contains. The equation is equal to molar mass of A. A is where Ma is the molar mass of analyte, Mc is the molar mass of compound, where A by B is the mole ratio of analyte to the compound from the chemical equation. I added an example where silver chloride, that is AgCl precipitates, where it contains Cl minus and Ag plus. So the AgCl decomposes into Ag plus and Cl minus. We are going to find out the gravimetric factor here. So molar mass of Cl minus is 35.45. Molar mass of AgCl is 107.87. So gravimetric factor is equal to molar mass of Cl minus by molar mass of AgCl. Here A and B are 1 because the equation contains each ion as 1 stoichiometric coefficient. So the gravimetric factor is equal to 0.247. This means that for every gram of AgCl weighed, 0.27 grams are due to Cl minus analyte. Okay. So the conclusion here, gravimetric analysis is an accurate quantitative method based on precise weighing of a precipitate. It relies on gravimetric factor for converting precipitate mass to analyte content. Highly reliable and precise with minimal contamination if done correctly. Widely used for determination of elements and compounds in various samples. That's all.